Today we are going to graph quadratic inequalities. To graph a quadratic inequality, first we're going to have to graph it, and then since it's an inequality, we're going to have to shade it to either above or below the parabola, or inside or outside of the parabola. The first thing to graph for this problem is this quadratic is in standard form. So to graph a quadratic in standard form, I'm going to use the x equals negative b over 2a to be able to find the x of my vertex. So a, b, and c, because in standard form it goes ax squared plus bx plus c. So now I'm just going to plug those numbers in, and that'll help me find the x of my vertex. So negative 2 all over 2 times a. Well, a is 1. Negative 2 over 2 equals negative 1. So the x of my vertex is negative 1. To find my y of my vertex, I'm going to take negative 1 and plug it into the original equation for x. So negative 1 squared plus 2 times negative 1 minus 8. Negative 1 squared is 1. 2 times negative 1 is negative 2 minus 8. Y equals negative 9. Because 1 minus 2 is negative 1. Negative 1 minus 8 is negative 9. So there's my vertex. Negative 1, negative 9. Now, to graph that, I'm going to plot it. Negative 1, negative 9. It's down here. I'm going to draw in my axis of symmetry. Remember, the axis of symmetry is a vertical line going up and down through our vertex. It cuts our quadratic in half. Now, up in the original equation, negative 8, that is our y-intercept. That's where our parabola crosses the y-axis. So I'm going to go to negative 8 on my y-axis, plot a point, then plot my reflection point. I am 1 unit away on the right side, so I have to go 1 unit to the left side. Now, before I graph this, look at your inequality. Greater than. If it is greater than or less than, we're going to use a dashed line. If it's greater than or equal to, or less than or equal to, we're going to use a solid line. So with this problem, negative 1, we plot our vertex, negative 1, negative 9. We plotted our y-intercept and reflection point. It is a greater than, so I'm going to use a dashed line. So we'll draw a dashed line going through our points, our y-intercept, our reflection point, and our vertex. And you'll want to extend this out. So now, we've graphed it, now we need to shade it. Now what we can always do is pick a point. Pick a point on your x and y graph. So think about what is the easiest point to pick on an xy graph? 0, 0. This point right here. So 0, 0, plug that in. Plug that in to see where it makes it true. So 0 greater than or equal to 0 squared plus 2 times 0 minus 8. Well, 0 is greater than 0 squared is 0 plus 2 times 0 is 0. Is 0 greater than negative 8? Yes. So where we shaded at is everything inside of your parabola. Okay, inside of your parabola. and it just keeps on going. Okay. So another way to think about where are the numbers greater than this. So if we would flatten the right side down like this, and if we flatten the left side down, we'd make a horizontal line. Okay, I know that's not very straight, but think about the numbers that are greater than that would be up above it. So then when you brought that back, it would still include the numbers inside of your parabola. Okay, this next one. And remember, you can always pause it, pick it up wherever you left off, okay? And, you know, you could pause it here. You try this problem, then, you know, watch me work it out. So A, B, and C. I'm going to use that x equals negative b over 2a to find the x of my vertex. So negative times negative 3 would be positive 3 all over 2 times 1/2, which is 3 over 1. So x equals 3. So the vertex, the x of my vertex is 3. To find my y, I'm going to take 3 and plug it in for x. So now I have 3 squared is 9, half of 9 is 4.5 or 4.5. Negative 3 times 3 is negative 9 plus 1. Combine those, I get negative 3.5. So my vertex is negative 3, 3, negative 3.5. So 3, negative 3.5 right here, in between 3 and 4. Negative 3 and negative 4. Draw my axis of symmetry. That dashed line going straight up and down. Plot my y-intercept, C. So I go to 1 on the y-axis and plot a point. I am 1, 2, 3 points away on the left side of my axis of symmetry. I need to go 3 points on the right side. Now, this is a less than or equal to. So less than or equal to, we are going to use a solid line. So after we graph it, we just need to figure out where to shade. Well, we can always pick a point. Now, with this, we could pick 0, 0, but it's getting really close to our parabola. So pick a number that's not near 0, you know, not near your parabola. You can pick any number over here in this region, or any number out here, or inside of it. I like to pick the same number that I got for my x and my vertex, 3. 3, 0, this point right here. Okay, 3, 0. So I'm going to plug that into my original equation. 0 is y. Well, the one reason why I like to plug it in is because I like to plug the same x in is because I've already plugged it in to find my y of my vertex. So I found the y of my vertex to be negative 3.5. The only thing that we're changing is we're changing our y. We're just picking that point. Is 0 less than or equal to negative 3.5? Is 0 smaller than a negative number? No, 0 is bigger. So this didn't work. So it's going to be everything on the outside that we have to shade. Okay? And another way to think about that, flatten that out. Flatten your lines out on both sides. See where the numbers are less than it. Numbers that are less than this should be below it. So same thing. I'm going to label A, B, and C. I'm going to plug those numbers into negative b over 2a to find the x of my vertex. So negative 4 over 2 times negative 1. Negative 4 over negative 2 is positive 2. Plug those numbers in to find your y. Remember, pause this at any time. I may go through this next problem quickly. So 2 squared is 4, so I'd have negative 4 plus 8 plus 2. Combine those, negative 4 plus 8 is 4, 4 plus 2 is 6. So there's my vertex, 2, 6. Draw my axis of symmetry. Now my y-intercept is 2. Plotting that point. I'm going to do my reflection point. I'm 2 units on the left side, so I got to go 2 units on the right side. This is going to be a dashed line because it is less than. Now here, the numbers that are less than, I'm thinking they're going to be inside of my parabola. But we can always pick a point. I'm going to pick 2, 0. And the reason why I did was because I've already plugged 2 in to find the find my y of my vertex. Now all I got to do is plug 0 in for y, plug 2 in for x. When I plugged it in, I got 6. Is 0 less than 6? Yeah. So did our point make it true? Yes. So I shade everything on the inside of this parabola. And the numbers less than this parabola are inside of it. We'll do one more problem here. Remember, you can pause this at any time to keep up and follow along. So I'm going to plug x equals negative b over 2a. So if I go up here and label it a, oh wait, I'm missing my x term. So I do not have a b. So b will equal 0 in this case. So 0 all over 2 whatever times negative 1. Well, 0 divided by any number is always 0. Okay? So we get 0 for our x. Now plug 0 in to get your y of your vertex. Well, 0 squared is 0. That doesn't change anything. 0 plus 4 is 4. So now I'm going to plot my vertex, 0, 4. Draw my axis of symmetry. Well, your axis of symmetry here is your y-axis. Now, if you're thinking to plot your y-intercept next, well, you've already plotted it. It's 4. So now, where do we go from here to graph this? Well, just like in vertex form, we had to pick a number that was close to our axis of symmetry to be able to plot a point and then a reflection point. So think about what numbers are close to your axis of symmetry of 0. 1, 2, negative 1, negative 2. Pick one of those numbers for x. I'm going to pick 1. Plug it in to your equation to see what your y is going to be. So 1 squared is 1. Negative 1 plus 4 is positive 3. So when we pick the point for x of 1, picked a number for x, plug that in, we got 3 for our y. So there's our ordered pair, 1, 3. I can plot that. Now we can plot our reflection point. I was 1 unit away on the right side. I can go 1 unit to the left side. This is less than or equal to, so it's going to be a solid line. So now all we need to do is figure out where to shade this. So I'm going to pick the point 0, 0 and plug it in. So plug in 0 in for y, 0 in for x. Is 0 less than 4? Yeah, 0 is less than 4. So that made it true, so I can graph everything inside the parabola, or shade everything. So there's a quick little video on how to graph quadratic inequalities.